This problem says evaluate the gravitational potential energy between two 5 kg spherical steel balls separated by center to center distance of 15 centimeters. Assume that they are both initially at rest relative to each other in deep space. Use conservation of energy to find how fast they'll be traveling upon impact. Each sphere has a radius of 5.1 centimeters. Okay, this problem shows you how weak the gravitational force is. So each of these mass is 5 kgs. Okay, and their center to center distance is 15 centimeters. And each has a radius of 5.1 centimeters. Okay, so the force potential energy is what we want to find. Okay, so the potential energy between the two is given by U is minus GM M product of their masses divided by R. Okay, so this is equal to, so let's evaluate this. Potential energy is minus 6.67 into 10 to the minus 11 meter cube kg second square. Their masses are 5 kg each square, and the radius is 15 centimeters, the center to. And we'll convert that into meters. Alright, so this is energy, so all these units should combine to give you joules. Okay, let's take care of powers of 10. This is 10 minus 11, and so you get 10 minus 9. So 10 minus 9 joules, and 6.67 into 25 divided by 15. Okay, so the potential energy is looks up to okay, so minus 11.1 into 10 to the minus 9 joules. That's 11 nanojoules. Okay. And then okay, so they're attracted toward each other and they'll fall toward each other, and they'll actually meet in the center since they have the same size now. And the question is, so at what speed will they impact? So now each will be moving with velocity v at impact, and what has happened is this energy, potential energy, is converted to kinetic energy at the end. So E initial equal to E final, kinetic energy initial plus potential energy initial equal to kinetic energy final plus potential energy final. Alright, they initially start off at rest, so the initial kinetic energy is 0. Okay, we'll need to add a page. Alright, so initial potential energy, we calculated that, it's this. Okay, so again, let me put in that expression. G minus gm square divided by r initial equal to mv square. That's the kinetic energy of one of them, and then the kinetic energy of the other, minus gm square r final. Okay, r initial, of course, the center to center distance was 15 centimeters. R final is when they touch each other, their distance between the centers is twice the radius, which is 10.2 centimeters. Okay. So mv square half plus half is 1, so mv square is equal to gm square r final minus gm square r initial. Okay, the mass cancels, so v is gm into 1 over r final minus 1 over r initial to the power half. Okay, so that's the impact velocity. That's the velocity of each one of them. What did they ask us? Assuming you find how fast they'll be traveling upon impact. Yeah, so that's how each one of them will travel at impact. So now we are ready to put in numbers. Okay. So V will be gm 1 over r final minus 1 over r initial to the power half. G is 6.67 into 10 minus 11 meter cubed kg second square, and the mass of each one of them is 5 kgs. Final is 10.2 centimeters. That's 10 minus 2 meters minus 15 into 10 minus 2 meters. And everything to the power half. Alright, again, let's take care of powers of 10 first. So this is 10 minus 2, that'll come to the top, become 10 to the 2. We'll pull that out, so that's 10 minus 9. 10 minus 9, that's, so what, we'll spend one of them, or, yeah, or maybe we'll make this, that's 10 minus 9, so we'll make this 0.66, okay, so we'll make that 10 to the minus 4, 10 to the minus 4 outside, and this is velocity, so this will be meters per second, so this will be 0.667 into 5 to the power half. So that's what it works out to. So each will be moving at this speed just before impact. Okay, so okay. Okay, so this works out to 3.2 into 10 to the minus 5 meters per second. Let's convert this to millimeters per second. So 10 to the minus 3 meters, 10 to the minus 3 meters is a millimeter, so that's 10 minus 2. So 0.032 millimeters per second. That's how slow they will be moving before at impact. Just goes to show you how weak the gravitational force is. All right, and that finishes this problem.